Good morning students. Today I shall discuss about the topic called data types in Java. Now before I go into detail what are the data types in Java, you should first know what are bits and bytes. A bit is either a 0 or a 1 and 8 such bits constitute 1 byte. That means 1 byte is equal to 8 bits. Now consider this number which is 100111011. This number consists of only two types of digits. Those are 1 and 0. As 0 and 1 are treated as bits, so we can say that this number consists of several bits. Now let's count the total number of bits in this number. This 1 stands for the first bit, this 0 for the second bit, this 0 for the third bit, this 1 for the fourth bit, this 1 for the fifth bit, this 0 for the sixth bit, this 1 for the seventh bit, and lastly this 1 for the 8th bit. So in total this number consists of 8 bits. Now as I have already mentioned before that 8 bits is equal to 1 byte, so this number which consists of 8 bits is 1 byte. So this number is a 1 byte number. Now this chart will show the different data types used in Java. The data type starts with char, boolean, byte, short, followed by long, float, double, and finally the string data type. Now let's discuss about the first data type, which is char. The size of this data type is 2 bytes. Now if the size is 2 bytes, how many bits of data can this data type contain? As I have already explained that 1 byte is equal to 8 bits, so 2 bytes shall be equal to 2 into 8, that is 16 bits. So this char data type can hold 16 bits of binary data. Usually this char data type can be used to store characters. Characters can be any letter from A to Z. It can be digits from 0 to 9, and it can also be symbols such as the dollar, percentage, ampersand, and so on, etc. The next data type is boolean. The size of this data type is 1 bit. As bit is either a 0 or a 1, so this boolean data type can hold either a 0 or a 1 as data. And in the boolean data type, 0 is treated as false and 1 is treated as true. So a boolean data type can hold either of the two values. It can hold 0 for false or a 1 for true. Now the next data type is byte. The size of this data type is 1 byte. As 1 byte constitutes 8 bits, so this data type called byte can hold 8 bits of binary data. This byte data type is used to represent signed positive and negative values. For example, -127 and +127. Both these values are the signed values. Because the number which is 127 in both these cases is preceded by a sign which is either a minus or a plus. For the first representation of the number 127, it is preceded by a minus sign. So it is a signed negative value. For the second representation of the number 127, it is preceded by a plus sign, so it is a signed positive value. Then come to the next data type, which is short. The size of this data type is 2 bytes. Okay, now since its size is 2 bytes and 2 into 8 is 16, so this data type, known as the short data type, shall contain 16 bits of binary data. And they are also used to represent signed positive and negative values. Now both these data types, okay, that is byte and short, represents the signed positive and the negative values. The only difference between these two data types, that is byte and short, is that the byte data type has the size 1 byte, whereas the short data type has the size 2 bytes. As the size of the short data type is higher than the byte data type, so the short data type can hold more pieces of binary data than the byte data type. Then come below, there are two more data types, which are int and long. The size of the long data type is more than the int data type, because the size of the long data type is 8 bytes, whereas the size of the int data type is only 4 bytes. But both these data types are used to represent the signed positive and the negative values. Now if we look at all these data types, that is byte, short, int and long, they represent signed positive and negative values, where the size of the long data type is highest, which is 8 bytes, and the size of the byte data type is lowest, which is 1 byte. Then come below and see this data type, which is float. The size of this data type is 4 bytes and it represents real numbers. Now when we talk about real numbers, then in addition to signed positive and negative values, it can also represent fractional numbers, okay, which is in the form of decimals, like this. This is an example, 234.09. Now if we look at the data types from byte till long, they can represent only signed positive and negative values, such as minus 127, plus 127, okay, of this type. But they cannot represent fractional values consisting of decimals, like this. But if we consider the float data type, okay, it can represent the signed positive and negative values, such as minus 127, plus 127, as well as the real numbers, okay, which is in the form of decimals, like this number, 234.09. Then come below, see the next data type, double. Its size is also 8 bytes, but its size is slightly higher than the float data type. This is because for the float data type the size is 4 bytes, but for the double data type the size is 8 bytes. And both these data types, that is float and double, okay, they represent the real numbers. The double data type, as its size is higher than the float data type, so it can represent larger real numbers. Now let's come to the last data type, which is string. Its size is of reference type. Now reference type means this data type called string can have any size, and that size depends upon the number of characters it contains. So string is a data type which is used to store sequence of characters. For example, we can say that the word apple is a string, the word mango is a string. Now if you look at the word apple, okay, how many characters does it contain? It consists of 5 characters. So this string apple, we can say it comprises of 5 characters. Again, look at this string called mango. It comprises of how many characters? It comprises of 5 characters. As the letter M is for the first character, letter A for second character, letter N for third character, letter Z for fourth character, and then the letter O for the fifth character. So in total, this string mango comprises of 5 characters. So we can say that this is a 5 character string. So a string is a very useful and commonly used data type in Java. A string variable is used to store sequence of characters. Now if you look at this variable, okay, identified by the name var1, it stores a sequence of characters. The characters are H, E, L, L, L. And at the end, there is a null character called /0. Now you remember that at the end of every string, okay, there should be a null character at the end. Same will be the case for the string called apple, okay. After the string called apple, there will be a null character at the end. And again, after the string called mango, there shall be a null character at the end. Now since this variable identified by the name var1 holds sequence of characters such as H, E, L, 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 /O, okay, so we can say that this variable is a string variable. Now this string variable contains the value H, E, L, L, L and then the null character, okay, and it contains this value at a particular memory location. Let's say this variable called var1 stores the value called hell at a memory location known as 512. So we can say that the string variable var1 contains the value hell and the null character /O at the address 512 or at the memory location 512. And that is the reason we say that the data type of the string variable var1 is a reference type. So this is a reference type variable and holds the reference or the address of the value stored in the memory. Then check this point. It says a string data is always enclosed within double quotes. Now this hell followed by this null character /0, okay, it should be enclosed within double quotes because this is a string data. Now if you look at both these string data, which are apple and mango, both of them are enclosed within quotation, right? Because it is mandatory to enclose a string data within quotations. So just as how you have enclosed apple and mango within quotation, in the same way you have to enclose the string hell followed by the null character within quotation. Now let's come to the next topic, which is literals. The values that a specific type can accommodate are termed as literals. Any single alphanumeric character, when I talk about alphanumeric character, okay, I can say that it represents a digit, letter or a symbol. Now see the word alphanumeric, okay. The alpha in alphanumeric represents letters, okay, and the numeric in alphanumeric represents digits. So alphanumeric represents digits as well as letters. And in addition to digits and letters, the alphanumeric characters also represents symbols. Digits can be 0 to 9, letters can be A to Z, and symbols can be dollar, hash, question mark, semicolon, colon, etc. And each alphanumeric character, okay, has to be enclosed within a pair of single quotes, and then this becomes a character literal. Example, when you enclose the letter A within single quote like this, okay, then it becomes an alphanumeric character, where this example represents the letter. Again, if you enclose the digit 1 within single quote, then it also becomes an alphanumeric character, as this digit 1, okay, enclosed within quotation or a single quote is a character which is of type digit. Then come here, this symbol $, when enclosed within single quote, also becomes an alphanumeric character, and it's of the type symbol. Now come below, this point says a set of 0 or more characters enclosed within double quotes are the string literals. Now this time I am going to enclose it not within single quotes, okay, but double quotes like this. Now when I enclose 0 or more characters within double quotes, this becomes a string literal, and the examples are hello, good morning, 1 2 3 A. As you can see here, the word hello is enclosed within double quote, so it becomes a string. Again, the word good morning is also enclosed within double quote, so this becomes a string. The number 1 2 3 is enclosed within double quote, so this becomes a string. And again, see the letter A, okay, even though it just consists of one character, it's enclosed within double quote, so this becomes a string. Now note the difference between this A and this A. This A is enclosed within single quote, whereas this A is enclosed within double quote. Now when any character is enclosed within single quote, this becomes a alphanumeric character, and when any character is enclosed within double quote, this becomes a string. So here this letter A in this case is a character, as it is enclosed within single quote, and here in this case this letter A, okay, when it is enclosed within double quote, this becomes a string. And another point, you need to note that the characters are always single. That's why you can see here that the letter A is single here, the letter 1 is single, okay, sorry, the digit 1 is single out here, the symbol $ is single out here. But for strings, they can be single, such as this A, but they can also comprise of a group of characters such as this 1 2 3. This comprises of 3 characters, where 1 is the first character, 2 is the second character, and 3 is the third character. For the string good morning, this also comprises of a group of characters. For the string hello, it again comprises of a group of characters. So keep in mind that characters should be always enclosed within single quotes as single, okay, whereas strings should be enclosed within double quotes, but it may be single or it may comprise of a group of characters. So here these are the character literals, whereas these are the string literals. Now let's discuss about the next topic, which is escape sequence character literals. Java offers a set of special character literals. These literals are called as escape sequences and used to display non-graphic characters on screen. Now if we look at these literals such as A, 1, $, hello, 1 2 3, okay, all these literals, they are graphical literals because they represent the graphical characters such as A, 1, 1, 2, 3, good morning. Okay, they represent the graphical characters on the screen which are clearly visible to us. But there can be some characters which may not be visible to us. We say those characters as the non-graphical characters. Examples of such non-graphical characters are the line break or a tab. Now, a line break is a point at which a text is split into two lines, and a tab is a group of 5 spaces taken together. Now both these examples, that is a line break or a tab, they are used to represent the non-graphic characters on the screen because they are not visible. The escape sequence literals are normal characters which are prefixed with slash, okay, and we treat this slash as a backslash. And you can see that here each of these escape sequences, they are prefixed with a backslash. The first escape sequence is /r, okay, which denotes the carrier's return. Now carrier's return is that escape sequence, okay, which is used to set the position to the beginning of a line or a text. The next escape sequence is /n, okay, it denotes new line. Now new line marks the end of the current line and sets the position to the beginning of the next line. Then the next is /f, it denotes the form feed. Now form feed is a page breaking control character. The form feed usually shows in printers. While using a printer, if you do not have sufficient space in the paper to print the characters, then the printer ejects the current page and continues printing at the another page. So the printer ejects the current paper and continues printing at a different paper. And in this way, the form feed is used as a page breaking control character. Then come to the next escape sequence, which is /t. It stands for tab. Tab represents a group of 5 white spaces. That means if you put 5 white spaces together, okay, that is equivalent to a tab space. Then come at the end, the last escape sequence is /b. It stands for backspace. If you look at your computer keyboard, you can easily find the key called backspace. And this backspace is used to put spaces from behind. Now if you look at each of these escape sequences starting from /r, /n, /f till /b, okay, they are not visible to us as graphical characters on the screen because they are in the form of spaces, new lines, and carrier's returns. But if you look at these literals, okay, they are visible to us as graphical characters on the screen. This literal is visible to us as a graphical character on the screen. They are visible to us as a group of graphical characters on the screen, which is good morning. This literal is visible to us as a graphical letter called A on the screen. This literal is visible to us as a group of graphical characters on the screen, which are hello. Again, this literal is also visible to us as a group of graphical characters on the screen, okay, which is good morning. Now let's come to the next topic, which is variables. A variable is a named memory space, the value of which can be changed during program execution. A variable works as a basic unit for storing data in Java. So whenever we store any data in Java, we make use of variables. A variable must be declared before using it. Okay, and the syntax of declaring a variable is like this. At first, you specify the data type of the variable, followed by the name of the variable, and then a semicolon. So this is the syntax. Specify the data type of the variable and then specify the name of the variable followed by a semicolon. For example, here int is the data type, okay? Here int is the data type and age is the variable name. And the statement int age declares a variable identified by the name age whose data type is int. That's why this variable called age can accept only signed, positive and negative values. Or in short, we can say that this variable age can hold only integer values because its data type is int. As I have already explained, these were the data types, okay, starting from byte, short, int till long. These data types can hold integer values which can be signed, positive as well as negative. Now in this statement, that is int age followed by a semicolon, I have declared only one variable called age whose data type is int. Now if I wish to declare more than one variable of the same type, okay, then I shall separate those variables with a comma like this. Now see in this statement, here I have declared three variables, that is age, year and total, and each of these variables are of data type int. That is just as how the variable age can take integer values, in the same way the variable year and total can also take integer values. And since I have declared three variables, so each of these variables are separated by comma like this, age, year, total. And these variables, that is age, year and total, can store integer values such as plus 127, minus 127, 5, 6, okay. It can store any integer values. Then come below, in this statement I have declared a variable called gender whose data type is char. Now that its data type is char, it can store only a single character, where the gender can store the value M for male or F for female. Then look at this statement, float weight. They have declared a variable weight whose data type is float. Now since float is a data type which represents real numbers, so this variable can take fractional numbers, okay, comprising of decimal parts. Examples of value that this variable weight can hold can be 68.2, 55.7, 10.9, etc. Then come below, look at the next statement, boolean is married followed by semicolon. Here boolean is the data type and is married is the variable name. Now since the variable called is married has the data type as boolean, so it can hold either of the two values. They can be 0 or a 1, where 0 stands for false and 1 stands for true. Now remember that a variable is a named memory space, the value of which can be changed during program execution. Okay, that means the value assigned to a particular variable need not remain the same. Okay, it can even change later on. Say for example, if you supply the value as 2, okay, to this variable called age, you can again in fact change this value from 2 to 7 or say 2 to 9, okay, during the program execution. This is because the values assigned to a variable is not necessarily needed to be fixed. The values assigned to a variable can change. So if you assign a particular value into a variable, okay, at the beginning of the program, then at a later stage of the program you can even change the value. Now let's come to the next topic, that is assigning value to a variable. The value to a variable can be assigned by using the assignment operator. Okay, we call this equality symbol as the assignment operator, and we assign values like this: a is equal to 21. Now see, as I have declared the data type of this variable age as int, so it can accept only integer values such as numbers. That's why I assigned the value 21 here to this variable called age as an example. Then see, next I have assigned the letter M within single quote to the variable called gender. This is because I have declared the data type of this variable called gender as char. Okay, now since char is a character data type, it can hold only letters, okay, and that should be single and enclosed within single quote. Now in this case I have enclosed the letter M, which stands for male, within single quote. Then see below, the variable weight has been assigned a value 60.5. Now since I have declared the variable weight to be of float data type, so it can represent real numbers, and real numbers can also comprise of fractional values, okay, which include the decimal portion. So this decimal number 60.5 can be easily assigned to the variable called weight. Next, the variable is married has been assigned the value true. This is because I have declared the data type of the variable is married as boolean. Now that boolean can accept only either of these two values, that is 0 for false or 1 for true. So I have set the value true to is married, okay. That means the value 1 has been set for this boolean variable is married, because true represents 1 and false represents 0. Now there are some variable naming conventions. The first point is a variable name must start with a letter, A to Z in capital or A to Z in small, or a $sign or an underscore. The second point is that a variable name must not contain embedded space, okay. Any variable that you declare, it shouldn't contain any embedded space or any other special character. Then Java keywords cannot be used as variable names, and variable names should be short and meaningful. Now look at the first point. It says a variable name must start with a letter A to Z in capital or A to Z in small. Now you see, if you look at these variables, okay, the variable age starts with a small letter A, okay. Now this clearly abides by the convention that a variable name should start with the letter capital A to Z or small a to Z, okay. In this case, the variable age here, okay, it starts with the small a. Then look at the second variable gender. It starts with the letter G, okay. Now since the letter G falls in the group of letters from A to Z, so this is also acceptable. Then come to the next variable weight. It starts with the letter W, as W falls between the letters A to Z, this is also acceptable. Then for the variable is married, as it starts with the letter I, this is also acceptable. So it can start with any letter, okay, and that letter can be capital A to Z or small a to Z, or in fact you can even start with a dollar sign like this. Okay, so this is also acceptable. Or you can start it with an underscore. So instead of dollar sign, if you put an underscore, this is also acceptable. Okay, so you can in fact declare variables starting with a dollar sign as well as an underscore, or with the letters from A to Z. The next point says a variable name must not contain embedded space or any other special character. Now embedded space means, see, this is a variable, okay, and its name is age. Now it shouldn't contain any embedded space like this. So this is not acceptable. This is not acceptable, okay. So don't put any embedded space like this. Or you should not contain any special character, okay. So don't put special characters like this. This is not acceptable. This is also not acceptable, okay. Obviously you can put dollar symbol or an underscore at the beginning. This is acceptable, so remember this. Then come below, Java keywords cannot be used as a variable name. Now what are the Java keywords? Okay, the examples of Java keywords are the data types. So these data types are the examples of Java keywords. There can be more keywords as well. So you cannot use Java keywords as a variable name. Example, we have declared a variable called age, okay, whose data type is int. Now here int is a keyword, okay. Now using int as the data type, okay, you cannot declare a variable name such as float, because float is a data type and so it's a keyword. You cannot declare a variable name as a char. This is also a data type. You cannot declare a variable name as an int. This is also a data type. So make sure that whenever you declare a variable name, okay, this doesn't become a keyword. So choose a separate variable name, okay, which does not conflict with the keywords such as the data types. And variable names should be short and meaningful. So try to keep the variable names as simple, short and meaningful whenever you declare. So with this I end my presentation here.